Hello, humans! Today we're looking at properties of parallel lines.
Don't forget the aliens. Hello to them also.
That,
Welcome to Earth.
that is fair. Or any non-human animals or plants that are paying attention as well. We'll
Correct.
welcome you too. All right, so we're going to take the stuff that we worked with in the last video as far as naming different types of angle relationships between parallel lines and transversals and talk about what that means in terms of the relationships between these things. All right, so the first thing we've got is about same side interior angles.
That's right. 3 and 6.
Yeah, and this is really interesting to me. So these are always kind of treated, you have to have one of these things be a postulate, something we accept that we can't prove, and then all the other ones kind of fall into that. And the fact that the resource that they were pulling this from chose this one to be the postulate is really weird to me.
I agree. I would have gone with like corresponding angles or something.
Any of the other ones, but that's fine. We'll work with that. I'm a huge fan of something that I call the PROT, the parallel line rule of thumb,
Ooh, okay.
which is that if we have lines that are parallel, things that appear to be true generally are true about the angles within a parallel line set.
I agree.
So one of the things that I notice, and again, like this is going to basically require us to think about another angle here, is that angle 6 and angle 7 appear to be equal. And since 7 and 3 make a linear pair, which means that they're supplementary, that means that 6 and 3 have to also be supplementary. And it kind of looks like they are. Like if you were to cut this picture and have angle 6 match up with angle 3, that the two of those together would add up to 180. And that's what we're accepting as true as a postulate so that we can talk about all of the other different relationships that we have here.
I was just writing down some notes. So you're saying if two lines are parallel, they have to be parallel. So then same side interior angles are supplementary. So in our previous section, we were talking about simply with the angle pair names. Which angles, if we have any two lines and a transversal, which ones are same side interior and alternate interior and all that stuff. Now we're saying, no, not this general picture that I just drew, but a specific situation. The lines have to be parallel. And if the lines are parallel, we're saying same side interior angles have to be supplementary.
I like it.
And now we're talking about alternate interior angles. So alternate interior angles, the two examples for those would be like 3 and 6 and 4 and 5. And we can do a quick little explanation of what's going on here. We just figured out that 3 and 5 added to 180.
I agree. We did figure that out.
And before, I guess we were told, we didn't figure anything out. Before, we knew that 5 and 6, because of the linear pair situation, add to 180. And you might notice I circled 5 twice. So 5 is involved twice, so that means that 3 and 6 have to be the same.
Oh, so this is like what we did with vertical angles and the weird supplement of the same angle and that type of stuff.
Basically, all these proofs are the same.
Cool. So that means that if 5 and 5 are the same angle, the only way that works is if 3 and 6 are also the same angle in terms of their size.
Yes.
So would it be fair to say that alternate interior angles are congruent?
It would be.
Cool. All right, so corresponding angles. Just going to remind myself what corresponding angles are. I like to think about this again as like position. So the top right angle goes with the top right angle on the other line. And I know Mr. Butterworth.
About which side is right, that's on this side where I'm coloring right now. That is the right side.
That is fair. So we talk about the positionality, the same position in each piece. Mr. Butterworth, you went a little bit further in terms of kind of specifying that these are one interior, one exterior, non-adjacent, and on the same side of the transversal.
Yes, which is a lot of words.
Cool. And it looks to me like we can do the same thing we talked about a minute ago, that we can look at these as a linear pair and linear pairs and kind of balance that. Or
Which ones are you looking at as a linear pair?
I was looking at like 2 and 4.
Okay.
And then since 4 and 6 are same side interior, we could do that. But I think a kind of cool way to look at this might be to say, we just said that alternate interior angles are congruent, so that angle 3 and angle 6 must be congruent. And we know that vertical angles are congruent. So I'm going to color this a different color. Angle 3 and angle 2 must also be equal to each other.
Ooh, is that like the transitive property?
Ding, ding, ding.
Oh, like that
And if angle 2 is congruent to angle 3, and angle 3 is congruent to angle 6, that means by transitive angle 2 must also be congruent to angle 6, which is what we were talking about for those corresponding angles.
So you said corresponding angles are, that's the eraser, congruent.
I like it. And if I had to, if I were a betting human, I would bet the next slide is about alternate exterior angles, which I've always thought is kind of a silly one because those are really easy to just show or vertical to other things. And just one more thing to memorize, but let's see if I'm right. I'm not. Oh, curses. Oh, we already proved this.
I know. I was laughing because I flipped to that page as you were talking. So again, we already proved this. Basically, use the fact that 3 and 6 are supplementary and 3 and 4 are supplementary, and therefore 4 and 6 have to be the same. The fancy statement you would make is angle 3 and angle 6 make 180. Angle 3 and angle 4 make 180. And therefore, these are the same and these are the same, so those must be the same.
I like it. All right. We've got to prove some things are supplementary. So I'm
These
just
are
going to...
same side exterior angles they're talking about, which our book never really gets into. And people don't really talk about, because again, if you know same side interior, why are you talking about exterior?
Yeah, and it's like, so based on my parallel lines rule of thumb, P-rot, like those look like they add up to 180, so we know that we're on the right track, which is always a nice thing.
Does your P-rot work nicely because there's basically only 2 choices with parallel lines?
It does.
So your only 2 choices are either the angles are the same or the angles add up to 180.
And in the past, when I've had geometry classes where we have a lot of proofs, once we get past kind of naming things, I'm okay with students writing P-rot instead of the various names of the theorems because it's much shorter. And generally, once you get that, you're okay with it.
Got it.
Mathematicians would not like that.
Not at all.
But that's okay. This looks like one that might be a good one for the students to try for a bit.
I agree. They should try this, and we're not even going to do it in the video. I think they should talk to us about it if they have questions.
I like it. I would like to note that I put dots next to angles 1 and angles 8 because that's what they're talking about there. Cool.
And now Nostradamus over here, this is what you were talking about. 2 lines of parallel alternate exterior angles are, well, let's see. Alternate exterior angles would be like angle 1 and angle 8.
Because they're on alternate sides of the transversal and are on the exterior of our parallel lines.
Yes.
Cool.
But we just figured out that angle 4 is congruent to angle 5 because of alternate interior.
Oh, yeah, I like it.
Or opposite interior if you want to go there. And then we also know that angle 5 is congruent to angle 8. And angle 4 is congruent to angle 1.
Why is that?
Those are vertical angles, and we just proved that. And now we're going to use the supertransitive property. Just kidding, it's just the transitive property.
So we're going from like 4 to 5, and then 5 to 8, and then 4 to 1. I was trying to go from 8, and I was like, there's no other 8.
Go 1 to
Oof.
4, 4 to 5, 5 to 8, 8 to
There we go.
7, 8 and 1 are the same. So if you wanted to write a whole big congruent statement, 1 to 4 to 5 to 8.
And therefore,
And you can just ignore the stuff in the middle. So 1 and 8 are the same.
I like it. Ooh, what are the measures of angles 3 and 4? I'm going to find 3. I'm going to find 4. And we've got 2 sets of parallel lines here. I see we've got arrows indicating that L and M are parallel, and then 2 arrows in red indicating that P and Q are parallel. I also noticed that like 3 and the angle that's marked 105 appear to be alternate interior angles.
Those are equal, right?
They are, because we have parallel lines that are cut by a transversal.
Is there anything else that's equal to angle 3?
I mean, angle 8 appears to be, they're both on the bottom right. So those would be corresponding.
How are those on the bottom right?
So I'm using the magic power of tourney stuff.
Oh, they're now on the bottom left.
Now they're on the bottom left. I could flip this, but then we'd see letters backwards, so we're not going to go there.
Got it.
So one of the things that's going to happen a lot is we're going to have 2 sets of crisscrossy parallel lines that look like a tic-tac-toe board. And if you're working on paper, one of my favorite things to do is to like literally just turn the paper so that we can see things better.
Mm-hmm.
If you're working on a Jamboard, clearly you can just use your fingers and turn that picture, and that's really helpful. We tend to function better for whatever reason if the parallel lines are horizontal.
Mm.
I don't really know why our brains perceive that better. Maybe it's just that we see more of those.
If I'm on my Chromebook and not playing with the Jamboard, can I just like rotate my Chromebook like this?
Oh, absolutely. Or like this if it's going the opposite way.
Oh, that's fun. So you said 3 was 105 because of alternate interior angles. And 3 and 8 are the same because of corresponding. Aren't 3 and 5 the same because of vertical?
3 and 5, yeah, they are. So that should be 105 also.
3 and 7 the same because of corresponding?
Or 105 and 7 are the same because of vertical. There are lots of different ways to figure this out.
Wow.
Oh, and then 6 too.
Right. So 6 is the same by either alternate interior or corresponding.
I agree.
So we just figured out that 3 was 105.
And so this process I often call angle chasing. And it's really helpful to just kind of go around and see what you can figure out before we dive into things. We got one answer. We need the other one, which is 4. But now this one it's not 105. The only other option that we have is that this has got to be supplementary to stuff.
Oh, so like you're saying, if I look at 4 and 6, those have to be supplementary because that's a linear pair.
They do. Or at 4 in the angle marked 105, those are same side interior angles and are also supplementary. So supplementary with 105, does that mean that the measure of angle 4 has got to be 75, so we add up to 180?
Yes, I hope the children appreciate how you wrote that 4 in the measure because it was like a wacky order of writing.
Yeah, I do that sometimes.
Rewind the video and watch that again because it was quite fascinating.
I think it was something like this.
No. You started the 4 weird. I don't know. The kids will watch it and tell us. So, but am I correct in saying we have 2 sets of parallel lines here, but we only have 2 choices for the size of angles?
We do. I agree with that statement.
So our choices are either 105 or 75. If we're writing any other number down, we're wrong.
That's correct.
Got it.
So would that be helpful to figure out first and then just decide, okay, is this a big angle or a small angle?
Sure.
It might. Ooh, this one's kind of wonky.
I'm going to redraw the picture because I'm scared. I'm going to redraw the picture. I got it. Don't worry.
Cool.
Okay, I'm done.
Oh, so what I see that you did was this line here, or this ray here, you just kind of left off because that makes it a little bit easier to see some stuff.
Yes. So then it looks like I'm talking about this angle right here. And
Mm-hmm.
so that same side interior.
Oh, and we know that same side interior are supplementary.
Yes. So that's 100 degrees because 100 plus 80 is 180.
All right, can I redraw the next part?
Yes.
So I'm just going to draw this in here. And I'm going to call this 100 altogether.
Ooh, I like it.
And if we know that part of this is 40 by the angle addition postulate, this has to add up to 100. I can't believe, I hate that postulate. I can't believe I just even used that as a
I'm very proud of
statement.
you.
Ugh.
It's good. It's a good one.
The only way I can get from 40 to 100 is to add 60.
What if I was scared? Could I write an equation like y plus 40 equals 180? Sorry, 100, not 180, 100.
You absolutely could. And then solving that, if I minus 40 to both sides, minus 40, we get y is equal to 60.
Oh, beautiful.
My 60s keep coming out like 66s.
You're the devil.
All right.
Ooh, a trapezoid.
Ooh, this looks fun.
It does, but I'm going to again redraw the picture. And I really suggest redrawing pictures, especially when they get confusing like this. Redraw it. Check it out.
Are you going to draw two different pictures or one big picture?
Two pictures. This is one picture. And then this is the other picture. Why flip the sides? I don't know.
I'm also going to draw a second arrow so that line is parallel to something.
I'm going to put two arrows on this one just for funsies.
Sure.
So now I have two pictures.
So it's like you're looking at this one here and then this one here.
Yeah, as I said, I don't know why I switched sides. If that's confusing to you, I apologize.
Because you're cray.
Apparently.
And then we know some stuff about, we've got parallel lines. In both cases, these look like same side interior angles.
They do.
And those are supplementary. So if I do the ones with y, if I want to make an equation, 3y plus 20 is equal to 180. That's going to give me 4y. I'm going to minus 20 is going to be 160. Y is 40.
And I'm doing the same thing. 2x plus x minus 12 equals 180. 3x minus 12 is 180. Sorry, I forgot what I was doing. And then 3x equals 192. And if I divide by 3, I'll get that x is
64.
64. Figured it out.
All right, so we figured out part A for x and y.
Well, there's a part B? Oh.
There is. What are the measures of the four angles in the figure? How about I do the x ones this time, you do the y ones this time?
Okay, can I erase the stuff you drew on the picture here?
Yep.
Sweet.
All right, so if x is 64, 64 minus 12 is going to be 52. And if x is 64, 2 times 64 is going to be 128. I'm going to check my math and do 52 plus 128, and I get 180. And that makes sense because they're same side interior angles.
Mr. Carlson, you make your dogs mad there?
I did, so I'm going to mute this while you explain your side.
Okay. I enjoy it. So y is 40, and I have 3y, so I did 3 times 40, which is 120, because 3 times 4 is 12, and then just put on a 0. And then we have y plus 20, and y is 40, so 20 plus 40 is 60. And again, as Mr. Carlson said, I can check it before I wreck it, and 120 plus 60 is 180. So it works out.
That it does. Awesome. You know, I think that's it. We're done.
It is. Yay! We did it.